Tekrar merhabalar değerli misafirlerimiz. Toplantının ikinci bölümündeki konuşmacılarımız Werner Kopp ve John Nelson ilk sunumlarında aktardıkları akustik ve ses yalıtımı ile ıslak mekan ve yangın güvenliği problemlerinin şimdi çözüm yöntemlerini sizlerle paylaşacaklar. Ayrıca Saint-Gobain Akustik Sistemler Küresel Pazarlama Yöneticisi Sayın Davy Vanekens, DB Station özel ses yalıtım simülasyonu deneyimini sizlerle paylaşacak. Öncelikle Werner Kopp'u tekrar sahneye davet ediyorum.
Okay, thank you. So, hello everybody, and welcome back. Thank you for staying with us. I'd like to start with a short recap on what I was talking about before. What we've learned, we agreed that noise can be very dangerous to the ambience. It can destroy more or less the ambience of a hotel that architects and interior designers have worked so carefully on to create. And we know from our experience that it's far cheaper and far easier to build in the right acoustical solutions from the very beginning rather than spending money on costly compensating measures afterwards. And it's also important that hotel guests are provided with a calm environment for keeping them capable, productive and safe while they travel. So this is really a responsibility of the hotel. They're responsible for the health and safety of their guests, and we strongly, of course, from Saint-Gobain Rigips, support this obligation, and we are happy to support you and the hotel chains with our technical solutions for that. We have talked so much about noise now, but what is noise actually? What do we need to know basically when we talk about noise and noise protection? So noise is more or less a jumble of sounds perceived by the ear. It can be described as unwanted sound. There's more or less two types of noises. I wish the sound file would work, but yeah, you have to turn on the volume, thanks. So it's basically two types of noises. It's the impact noise passed on by parts of the building structure. Typically, you hear footsteps, you hear the door slams, you hear the elevator arriving. But the more annoying one is really the airborne noise, which is transported by air, and I would like to focus a little bit more on this airborne noise. So, what do we need to know when we talk about noise protection? We can... How do we need to know first, if we talk about noise protection, how do we actually perceive the noise, or how do we hear? So for that, I'd like to take you through a little experiment. If you have two equal sound sources, for example 80 dB, and you add an identical sound source of 80 dB to the first one, what do you think would be the result? So if you have, for example, a very annoying sound of 80 dB, and you add the second one, what do you think would be the result? Will it be 100 dB, 120, or? Well, very close. Actually, it's 3. It's only 3 dB. Of course, it is twice as much as annoying, but it's only a plus of 3 dB. And this is why. On the y-axis, you have the difference in sound level, the difference in dB, and on the x-axis, you have the difference in dB, and on the y-axis, you have the difference in the noise. And when you look at this curve, no matter how big the difference is between the two noise sources, you can never gain more than 3 dB. For example, if the difference is more than 9 dB, does it work? You hear? Oops. Health and safety. So the notable difference is below 1 dB. So that's why 90 dB plus 80 dB will give you in the end 90 dB. I mean, that's good for us because we only have to focus on the loudest sound source. If there are two people in the neighbor room, we just pay attention to the louder one. So how can we protect ourselves from noise? We can try to control the noise source, which will not work very good. We can try to move away from the noise source, but we cannot just simply leave the room. But we can build noise barriers, in this case in the shape of a partition. And basically a partition, the higher the R value is, the better is the sound insulation for the partition. Of course, it depends on the noise source, on how the receiving room is built, on the surface and the absorption of the surfaces, but also on how good the partition is installed on site. And for that, you need to have safety factors. And in this table you can see our recommendations. So we propose a safety factor for the partition of plus 7 dB, and this is in line with European residential standards and what leading hotel chains propose, and it's also based on our expertise. For example, if you have a partition designed of 62 to 72 dB, you can find it on the right hand of the table, it will give you in practice a performance of 55 to 65 dB. So it's 7 dB less than the actual value of the partition is. And you always need to have this in mind. So when you read the partition gives you 60 dB, it's not what it gives you on site. You always have to reduce it at least with 7 dB. Because there's a lot of safety factors in it. This flanking transmission, it can be bad installation. This does not only apply for plasterboard systems, but also for bricks and concrete. Pretty much any partition on site needs to be treated with a safety factor. So the difference between our systems and the traditional ones which you would use is our systems are obviously lighter, up to 10 times lighter. You can install them 3 times faster, and you have a reduced thickness, up to 30% thicker, but with the same or better acoustic performance. And this is a real advantage when it comes to, for example, hotel buildings, high-rise buildings, residential buildings, offices, whatever. So it's not only the advantage in sound insulation of our partitions because of the mass effect that we will explain later, but it also can save you money because reduced weight saves you a lot of concrete, a lot of structural reinforcement. Faster installation helps you to complete your project earlier. And reduced thickness, for example, in residential apartments, you have a lot of more square meters to sell to your customers. And we carried out really a lot of studies verified by third parties, and the conclusion was, on average, really for a high-rise building, a hotel, we can save you with our systems 20% of total construction costs and can achieve up to 7% cut in the total investment. Because hotels are not only built to set architectural landmarks, they are more or less built to generate money. And the investor wants a quick return on investment. And if we can help him with that, I think we would be his preferred choice for the project. And remember, these are no assumptions. These are real studies that have been carried out by us over the past years. So maybe if you're already convinced that our systems are the preferred choice for that, how do you find the solution? Well, the easiest thing is to use a system selector. You will find a template of this in the hotel brochure on your seats, which shows you a lot of different systems. And it's not only about sound insulation. All the systems need to cope with different challenges. So they have to provide moisture resistance, they have to provide impact resistance, they have to provide thermal insulation. So it's really up to you then to pick from our systems the one you need and put it on the right position. And this really, altogether in the whole project, will save you a lot of troubles and a lot of time and a lot of money in the end. So everything you hear together today is linked together, and my colleague David Venikens will show you how a tool like DB Station can support you with that.